Bismillahirrahmanirrahim. Assalamu alaikum. We on to the third lecture of data and computer communication. Today is our third lecture actually.
My name is Engineer Jaffar Ali. I am your instructor for this course. Let's see what we are going to do today. Today we will be looking at some basic overview of networking, that what is the need of layered architecture. We will see that what is layered architecture, and after that we will see that what is OSI reference model in very much detail.
Now, starting with the very basic of networking, it is very essential, or you can say very necessary, to understand a basic OSI model. Now, what is OSI model? So, starting with OSI model, you see that it's termed as OSI. Basically, stands for Open System Interconnection, and it was developed by ISO, that is International Standard Organization, in 1984. This protocol, or this basically model, this is known as a reference model. The term reference means that it is not practically implemented, but the worth of this protocol or model is of that importance that all the coming or forthcoming models will be based on this protocol. It is not by itself implemented, but its implementation, the other implementation of other models will be based on this OSI model. So that is why we are learning OSI model in today's class. Now, what was the purpose of OSI model? You see that before this model, there was need of communication between devices. So, to fulfill that need, one have to come with an idea. So, before OSI model, the things was very in form of jumble order. There was no basic standard or protocol that was to be followed while networking or communicating with other devices. So the whole communication of networking was termed as single piece. So there was the need to have a divided, or you can say modular approach. What is modular approach? Modular approach means that you take a problem, you divide a problem into sub problems, multiple problems, and you then solve each sub problem, and the solution becomes very easier as compared to solving a whole problem by itself. You are students of computer science. I hope that you have gone through a basic idea that what is modular approach. Modular approach, I repeat again, that you take a problem, you divide it into several small problems, and you solve those problems, or you can say you give tasks to different people to solve those problems. You see that if you have any experience in development side, so a one person or one team cannot build whole website or web domain or anything by itself. So they divide the work in different portions, and the portions are termed as modules, and each team is given a different module to work upon. So that is why the problems become very easier, and it is very easy to solve. And if in future there is a need of some troubleshooting, or you can say some modification, so there is no need to resolve the whole problem by itself. You just go to a particular module and you solve that module instead of solving the whole problem again. So that is where the OSI model comes into play, and this was the basic purpose. Now, purpose of OSI model, as shown in the slide, that this model basically provides a bridge between different systems that want to communicate. Those systems that do not want to communicate or does not need to be part of network, so they do not have to follow SI model. But that system which need to communicate or which need to be part of a network, that need to follow OSI model. So I've given the note that OSI is not a protocol, it is a basic model for understanding, and I've told you that this model is not practically implemented. But all the practically implemented models are based upon this model. So if you have learned about this model, you do not need to have to worry about other models. You just replicate this model into another model, and we will look over that in the coming lectures. Now, coming towards what are the basic rules that need to be followed when you are developing some model, or this model was developed on which rules. So, any model or this model which you want to build can be built upon some rules, and the reason why we followed the rules is that to have some main target or main objective. So what was the main objective while designing a OSI model, or you can say any of the model that you want to design? A model should be least complex as much as you can, and the reason is because you do not want to go into confusion in future, because you see that if you work on a project and after some time you left the project, or you complete the project, and after 1 year or 2 year or any specific time you come back to those that project, it is very hard to understand your own project. So it is very much desirable to have such a model that is very much less complex, so that in future when you come back to that model, you need to have to worry about the complexity level. You can understand which function perform what task. So a model should be less complex. Each layer should perform a well-defined task. So what does this mean? So you see that you have to divide. I have told you that you have to divide a big problem into a different small problems. Similarly, you can say a model is divided into instead of one body or entity performing the whole task, you divide body into different layers, and each layer performs that different task. So the each layer should be performing similar task. I mean, if you are in for example first layer, so the layer first will be those functions which are in layer 1 should be similar to each other, because if you are performing a function in layer 1 and that function is also performing in layer 6 or layer 7 or any layer, so you see you are replicating it, means you are making it complex to try to use similar function in single layer. If you are trying to do different function, you are trying to go for a different function, you can use another layer. But if you are in same layer, try to use similar functions. The third rule can be that the numbers of modules or layers should be optimal. Optimum means you cannot create many of layers, or you cannot create some of the few of the layers. You have to have some standard, some you can say basic fundamental that need to be followed. Optimum layers means that your number of layers should not exceed too much or should not be minimized too much. It should be in between somewhere, but the function does not affect the model. The model should not be affected. Keep it that in mind. The numbers of layers should not affect the model. If it is affecting the models, that means your model is your numbers of layers is not optimum, because it is disturbing the model or other functionality. That means compatibility. If you are performing a task in layer 1 and it affects or it creates ambiguousness in layer 2 or layer 3, so that means your model is not compatible. It means that by changing a value of a function in layer 1, and layer 2 gets disturbed from the modification that we have done in layer 1, so it means that your model is not compatible. So you keep in mind that when you perform a function in layer X, so the model should be of such kind that another layer should not get affected. Now coming towards the introduction of or the brief of OSI model, you see that there are 7 layers. OSI is basically 7 layers of model. The first layer is starting from the very bottom is physical layer. The second layer, layer 2. Keep in mind that these layers are termed in practical industry by L1, L2, L3 and up to so on. So L1 basically represents physical layer, L2 represents data link layer, L3 represents network layer, L4 represents transport layer, L5 represents session layer, L6 represents presentation layer, and the last or the first layer, L7 represents the application layer. I have provided you the links, the hints over here that how do you remember these. So all people seems to need data processing. The first letters that are bold presents the first letter of the layer names. And with that, I've also given you the format of these layer, that in which layer the data which you have given in the system is presented at what form. So in application layer, data is normally present at text or numbers, etc. In presentation layer, it is basically a raw data. In session layer, you create dialog. We will discuss each and every form of these formats in the coming slides. but this is just for overview, so you can have an idea that what we are going to learn today. And with that, I have given you the usage. That is very important. You see that if you are a client, you can say the user, so you are basically at the client side, host side. So you are basically are at the host end, or you can say user end. So you are using application layer, presentation layer as session layer. You do not use physical layer, data link layer, and you don't have any concern regarding that, because that is the part of the back end. You can say the back end. You have learned about the front end and the back end. The front end basically is the application layer, presentation layer, and session layer, and the back end represents the first three layers, L1, L2, and L3. That is physical, data link, and network. This is decided by the backend, or you can say the host, server. That will decide. The server will decide, or the network creator or administrator will decide about these parameters involved in these layers. But you can create, you can change or modify the some of the protocols, not all of them, some of the protocols above these layers. That is application layer, presentation layer, session layer. I will take you to some of the examples, practical examples, where you will see that how you can manipulate application layer, presentation layer, session layer in your simple Google Chrome or Mozilla Firefox or Opera or any browser you want to. Now you see that I have described the host and the network end, but there is a need of a bridge that connects the host end to the network end, or the client end to the server end, and that bridge is basically transport layer. Some people say transport layer is a part of network layer and end up as well as a part of the user end, but some people also say that transport layer is neither the part of both of these layers, and both have their own facts and figures, and they both are right. So there is no need to go in that deep discussion. I personally believe that transport layer is not a part of both of these entities, because it is basically a bridge, and bridge is not a part of both of the ends. It is just a passage to pass. Now coming toward a physical representation or overview of OSI model, you can see that starting from the application layer from one end, that you can say user end, and towards the host end or server end, you can say a data is fetched from application layer from one side, and it goes to physical layer bottom, the bottom of physical layer, and it travels through the channel, and it goes towards the physical layer of the second end, and again user end or server end, and from the physical layer it goes above to the application layer. So it basically starts from the application layer, and it travels towards physical layer by itself, and from physical layer it goes towards the physical layer of another through a transmission media or anything, and from the physical layer of the second user it goes towards the application layer and displays on the application layer. You can say Chrome or anything. Now, what is the organization of these layers? I've already told you that the first three layers, L1, L2, L3, are basically network support layers, and it supports, or it is administered by the network side. And the last three layers, layer 5, layer 6, layer 7, that are basically user support layers. It supports the user, and it helps you to manipulate the data as your requirement. I will not be teaching you how to manipulate data, but I will show you how you can understand these things. I have already told you that layer 4, that is transport layer, that is not a part of any of these port layers, but it is somewhere in the middle, and it performs as a bridge between these two layers. It performs connectivity. Now, implementation of these models is very important to understand that the upper layer of OSI models can be implemented in software. As I've told you that the application layer, physical presentation layer, and session layer, you can manipulate data in any, you can say, browser or any software if you want to. So these are basically developed in software. Lower layers are basically a combination of software and hardware. You see that there will be we will see routers, switches, hubs, etc. So these layers will be mostly in software and as well as hardware, but the physical layer is majority of hardware, because you need to have modulators and different kind. We will look over that in coming slides. So the physical layer will be mostly comprised of hardware. Now, what are headers? Before going to the digging deep into the OSI model, we need to understand what is headers and what is a tail, so that you can have the idea about the formats of data that we discussed earlier in the earlier slides. Now headers are something that need to be placed before the packet, so that the lower layers can understand that the data was coming from which layer and it has done which task. The header shows that the layer, basically the data has come from which of the above layer and it has done which task, so that it cannot repeat the same task, or it cannot damage our data. It knows that the following headers shown following work. So header shown basically the layer. So every data has to add some header before sending it to another layer. You see that in this example, in this diagram on slide 12, you see that the data from the user is inserted or embedded or uploaded in the application layer using an application layer protocol. We will discuss different protocols in the coming slides. So the application layer basically puts a AH, that is application layer header, before the data, and then transfer it to the presentation layer. Now this presentation layer knows that the data has the header of AH, means it has come from the application layer, and application layer has done following modifications in the data or with the data. So it will carry further process by instead of gambling the data or modifying the data randomly, it will process the data accordingly in sequence. So after processing it, it will put a PH header, that means presentation header, and it will further send the data or transmit the data to the lower layer, that is session layer. Similarly, all the layers will put a header of its own identity that will show the lower layers that the data has come from which layer and it has done which task. Header shows basically in header there is also a entity or a space where it is mentioned that this data has been performing this protocols or this task. This will make the lower layer understand best about the data. Now starting in detail that what is application layer, I have told you that it is used by application that required to operate in some network. You see that you, if you want to go to web server, you can use Google Chrome. So it means that Google Chrome need to be a part of server. So that is why Google Chrome is a basically a network layer application. Similarly, Skype, if you see, if you do not want, if let's say there is no internet and you want just to see some PDF files, you want to see some PDF files, so you do not need to have internet connectivity, so you can use your Google Chrome as a PDF viewer. But in that terminology, Google Chrome will not be a part of application layer. It will not be application of application layer, because you are not connected to the internet. Only for those applications, that for that you need to be a part of internet. For example, let's say you need to have an email, you want to email somebody, so you have to be a part of a network. For that reason you will use let's say Google Chrome, and in that terminology Google Chrome will be termed as application of application layer. Similarly, if you want to Skype somebody, you need to have internet connectivity. So Skype is basically application of application layer. Similarly, application layer performs many other tasks. It enables the user, either human or software, to access to the network. It provides a user interface and support to the services such as electronic email, remote file access, a file transfer protocol, etc. Different there are different protocols that you will be seeing in the book or in the coming slides, etc. So these are the main functions of application layer. Application layer helps you to transfer the file, manage the files, mail services, directory services. It is given, you can read it, it's very easy to understand. Now what is presentation layer? Presentation layer is concerned basically with the syntax and cinematics of the info exchange between two systems. The name shows that you have to present the data in some ordered manner, in some particular regular manner. You cannot jumble up the syntax. So there is a need of some body or some entity that cares about the syntax of the data. So there comes the role of presentation layer, and presentation layer helps to control that syntax or modify that syntax according to the system. You see, you when you enter some data in Google Chrome, it is basically in your terminology, it is not in the terms of computer. So somebody have to need to convert that data into a machine understandable language, and that where presentation layer comes in. This is the layer which cares about the syntax or cinematics between for the data or of the info to exchange between two systems. Now, what are the functions of presentation layer? As we have already discussed, there are three basic main functions. Uh, they are now coming towards the functions of presentation layer. There are basically three functions that we will be discussing. The first one is translation, the second one is encryption, and the third one we will see in the next slide, that will be data compression. Now, what is translation? I will show you another slide. In this slide, you can see that there are the three functions. One is translation, data compression, and encryption. These three are very basic and very essential for any network to do. The functions are, the first one is translation. You see, you have given some jumble ordered or jumble word ordered word, and computer does not understand what type of data you have entered. So it basically converts that data into some proper format. You can say, for example, ASCII codes or any BCD codes or any code. So basically you convert the data from the user to a machine understandable language, and that could be any of the codes. And after that, the second functions of the presentation layer comes in, that is data compression. This data compression is very much essential nowadays, because as the number of users are getting are enhancing, the need of the need of the more speed is also getting higher and higher, because everyone wants to be at good transmitting at a good speed or receiving at a good speed. And for that reason, there are two options. Number one option is that you can have a huge amount of bandwidth to increase your speed. Basically, you need two options. Either you can enhance your bandwidth, but it will cost you, or you can reduce the size of data. These both techniques can enhance your speed. So rather than going towards the costly option, that is enhancing your bandwidth, one anyone wants to go with the data compression. And what does this data compression do? This technique basically compresses the redundant bits. What are redundant bits? I'll show you that. Let's say, for example, you can see that all of the my background is of same color, means they are approximately of having same bits in terms of computer terminology. So rather than sending all ones at the back end, I will only transmit one that will show the color of one pixel, and with along with that I will send the frequency, let's say 10. So means 10 times 1. So rather than sending 1 1 1 1 1 1 1 1 1, I will send 10 1. It will mean that I have compressed the data and have put some frequency that repeat 10 times, or you can say 100 times. It will, as much as you want to compress your data, this is known as basically compression ratio, that how much you want to compress your data. If you want to go higher, you go with a higher compression ratio. So it can be done, but there will be a huge chance of error. If you see that I have converted all the ones to all the data into single entity, after receiving the at the reception side, there will be no clear distinction. There the image will be blur. If I say that I've given you the example of my background, it can be you can understand from here right now. But if I send you this data after data compression, maybe you do not have the ability to differentiate between different minute changes. That way, where the term compression ratio comes in, and somebody need to have look over this data compression ratio. So it is very important to compress the data before transmission, to reduce the size, as much as possible, but not at the cost of the quality. You cannot degrade your quality too much to enhance your data speed. That will be resulting in nothing, because if you want to if you compress too much of data with a higher data compression ratio, so the result will be nothing, but because there will be no clarity, there will be confusion, ambiguity, blurriness in audio, video, extra. So this is where you need to have a look over it. The third one is encryption. Before sending the data towards the lower layer, presentation layer basically encrypts. It means encode data in a form, so that the security need cannot be compromised. So it is basically a security function that a presentation is performing. That is, it encrypts the data so that and you see that most of the banking, online banking, and where any websites or any domains that use transfer of money use HTTPS rather than HTTP. HTTP is application layer protocol, and this small s, which is in there in the domain, you can see any of the websites, Draz.pk or any of this website, you can see that they put a small s, HTTPS. This s shows basically that it is secure socket layer, means it encrypts your data. Because you see that the online banking or online transaction, money transaction, is very much of a threat nowadays. So to ensure that security, this layer is also embedded. That means you encrypt your data before transmitting it. Now coming towards session layer. Session layer is basically a dialog box, network dialog controller. Basically, it establishes, maintains, and synchronizes the interaction between communication systems. You see that if you are working on a system and you have open different applications at a single time, you are listening audio, taking downloading video, and mailing to someone or receiving a mail from someone. So how does the computer know that which file goes to which application? There comes the role of session layer. It maintains, establish, first of all it establish a session, and it maintains that session, and it synchronizes interaction between these communication devices. The best example of presentation layer along with the session layer is online banking. You see that if you are using online banking and you have opened your account on your mobile, on your iPod or your system, so after logging in, if you do not use your account for 10 minutes or 20 minutes, this the website automatically logs you out. The reason because is that the session layer controls, as I've told you, that establishes, maintains, and synchronizes interaction. So there is a command that is basically involved in it. This command tell the presentation layer that the user is not interacting for about 20 minutes or 30 minutes. So it's better to make the account secure, and let's log him out or log her out. The reason because is to maintain the security level. Now, what are the functions of session layer? I've told you that first of all, it opens or it controls the dialogue between different bodies and different sessions at the same time. Similarly, it provides synchronization as well. You see, if I'm emailing someone and at the same time I'm using Messenger to message someone on the Facebook, so it will provide both of the functions at the same time. So session layer will be ensuring this, that the mail should not go to the messenger, and the messenger text should not go to the mail. The another function that is provided by session layer is first one is authentication, authorization, and session management. Verifying the user is a part of authentication. Checking whether you have the access permission to access the file that is somewhere on the server, that is known as authorization. And session management is where you receive the packet, you transmit the packet where it belongs. So these are also the functions of session layers. In transport layer, basically I've told you that transport layer is basically a bridge between the host entity and the network side. So it is responsible for source to destination delivery for the entire message. It also ensures that the whole message arrives at the destination intact. Means that it ensures the reliability of the network. Any network, the important factor, there is important factor called reliability in any network. So that reliability is ensured by transport layer. Now, what are the functions of a transport layer? The first function is termed as service point addressing. It basically gets the port address actually to deliver the message at the right port. For example, if you are using multiple programs at the same time on a same system, so it is very desirable to deliver the message at the same application there it belongs. So for that reason, service is known as service point addressing, and it is also termed as port address. It means that the by the desired port or the application. The other function of transport layer is it basically segments and reassemble the packet. As you know that the size of packet matters a lot. If you are transferring a data or any message basically, and the message size is too high, so it is not possible, and it is not recommended. Even it is possible, then it is not recommended to transfer the message into in a single file. Same is the reason that I am trying to divide the lecture in two parts, because if one of the packets get lost, the whole entire message will be corrupted or lost. So to reduce the amount or chances of or probability of corruption and losses, it is highly recommended to divide your message into small segments. And at the receiving end, divided message is also reassembled. So the division of a message is known as segmentation, and after reception, the combination or reassembly is done at the receiving end. This is all done by transport layer. Also, the other function which is very important of transport layer is flow control. You see, if you are communicating with a server, and the speed of the server is, let's say, 100 mbps, sorry, and your device cannot handle more than 10 mbps. So basically this is the transport layer which tells the server to slow down their processing speed as per your demand. The server can transmit up to 100 mbps, but your device cannot be able to handle that effectively. So this transport layer will send the information to the network and to reduce the speed from 100 to 10 mbps or any value. Other important functions, as we have already discussed, that transport layer is basically the bridge. So it has to ensure the reliability, so it will be working with both of the ends. So to make it a good and reliable communication, the function is known as connection control. The communication between a transmitter and the receiver can be done in two ways. One is connectionless, and another one is connection oriented. Connectionless mean that the transmitter do not have to establish or dedicate a fixed path towards the receiver. And in connection oriented mean that the transmitter have to dedicate a specific path towards the receiver for all the communication. So you see that all the communication in connection oriented will be go through the same path. And in connectionless service, it is also possible that one packet goes from one route, and the another packet goes from another route. So this is the difference between connectionless and connection oriented. UDP is basically connectionless. This is known as user datagram protocol, and it is faster than TCP because it do not wait to find the basic route path towards the receiver. It simply transmits the packet, so it is faster than TCP, that is transmission control protocol, that is connection oriented. In TCP, we have to wait for a path to establish, or a connection, or a channel to establish, or a route to find out, which will be seeing in the coming slides, that how a route can be found out. For services like online gaming and live streaming where you need fast streaming or fast speed, you go for UDP. And for important emails and where such applications where the reliability of a data is must, for that reasons we go for TCP. Now coming towards the next layer, that is network layer. So network layer is responsible for source to destination delivery. Network layers also ensures that the packets get from its point of origin to its final destination. That means transmitter and the receiver. These terms are basically denoting the transmitter and the receiver. So a network layer oversees the source to destination delivery of entire packet, but it does not uh, the difference between this and transport layer is that it does not recognize any relationship between those packets. For example, let's say all the packets are same for this network layer, so it does not discriminate or differentiate between these packets. uh, but this network layer, I have also told you that is important and responsible for source destination delivery. That is the reason it treats every and each and every packet independently, so it does not it does not have any idea about the relationship or dependency between the packets. Now, what are the important functions of network layer? The first very important function of a network layer is logical addressing, means IP allocation. You already know about IP in data communication, so no need to go in depth in that. We will look over IP addressing in the coming lectures. Function of network addressing is basically routing. And what is routing? It is basically a method to move a packet from source to destination, and it is based on IP allocation, that is logical addressing. So now it includes the routers that are interconnected in inter-networking devices. So here comes the part of hardware that I've told you in the previous part of the lecture, that in the last three layers mostly there are a combination of software and hardware. So here comes the router, which is a hardware device. Basically routing is finding the path from the transmitter to the receiver. And we will be studying several protocols in the coming lectures. The some major or famous protocols are OSPF, that is open shortest path first, and BGP, that is border gateway protocol. After that there comes a data link layer. So data link layer is responsible for node to node delivery. It receives the packet from the network layer and creates frames rather than segments, which were generated by transport layer and given to the network layer. And these frames actually basically are so data link layer is responsible for node to node delivery. It receives the data from a network layer and creates frames. Then it adds physical address to these frames and pass it to the physical layer. You see the diagram is showing the same process that I have mentioned above that. What are the main functions of data link layer? The first main function of data link layer is framing. It means it divides a bit of streams into small frames that are easy to handle, that are easy to manage. Similarly, the other function that is very important is known as error control. I hope you have already studied error control, error detection, error correction. So that is why I will not go in depth. But there are several protocols like parity checks, checksum, CRC. You can ensure the correctness of the message or the bits. The most important protocol, the most important function of data link layer is access control. Basically, data link layer is divided into two subgroups. One is LLC, that is logical link layer, and the other one is MAC, that is medium access control. And this medium access control, I hope you have studied about Aloha, slotted Aloha, pure Aloha, and different techniques, scheduling, polling, token ring. And the most commonly used is basically CSMA and CSMA slash CD slash CA, collision detection and collision avoidance. So these all are basically there to ensure that there is no collision among the devices which share a medium. For that reason, we are using access control in data link layer. The first layer, here comes the first layer of OSI model, that is physical layer. This layer is basically responsible for the transmission of data towards the receiver. It basically deals with the mechanical and electrical specifications of the transmitter, medium and interface. Now what is transmitting medium and interface? Interfaces are basically the connection or links between different entities in an OSI model, and transmission medium is basically a channel that is that is established from the channel to the receiver, from the transmitter to the receiver, and it can be either wired or it can be either wireless. The main functions of physical layer involves, as I told you, that it is basically the last layer, or you can say the first layer, and it is directly connected to the media. So the responsibility also incorporates the properties of media or interface between the transmitted and transmitting device and the medium. So it basically reduces the acts as a bridge between the OSI model and transmission media, and it also represents the bits in the encoded, so it can be secured. You see that we will use different modulation techniques. You have studied, I hope you have studied different modulation techniques and line coding techniques, in which I just want to tell you that basically in analog system we use modulation, and for digital system we use line coding technique. So in both of these cases, bits need to be get to in shape of a signal. For that reason, we have to represent the bits in terms of signal, either analog or digital. And for that purpose, this physical layer uses modulator or line coding techniques, etc. It also physically also manages the data rate and transmission rate. And data rate, you mean number of bits per second, and the baud rate, if you are using an analog system, you might have heard about baud rate. So baud rate is number of signals per second, and bit rate it is number of bits in that signal, basically. And so it is also ensured and managed by the physical layer. Now what is synchronization of bits? Synchronization of bits mean to make the receiver and the transmitter clocks at the same time, to encourage them to be synchronized. It is the reason, because of that, is to reduce the amount of error between the transmitter and the receiver packets. So it is also done by physical layer. The other parameters are line configuration, physical topology, transmission mode. Either the user want to go with half duplex, or he want to go with full duplex. So it's also ensured by a physical layer. Here is a summary of all the OSI model, starting from the application layer, where the network allow access to the user to its resources. Then it is presentation layer. Presentation layer basically translate, compress and encrypt the data. Then comes the session layer. A session layer establish and manage and terminate different sessions. Transport layer provides a reliable end-to-end message delivery and error recovery. Network layer basically move packets from source to destination, providing them a path, and known as routing. And data link layer then organize the bits into frames and provide node to node delivery. And the last or the first layer of the OSI model, that is physical layer, it manages mostly about the channel or transmission media. In reality, there no data are directly transferred from one layer to another layer into the machine. Instead, each layer process and control the information to the layer immediately below it. You see, no, there I've given an example: host A and host B. If host A want to transmit to host B, it cannot directly communicate with the host B. So it will follow all the OSI model layers, and it will pass the data to the physical layers till the end, and the physical layer will be responsible to transmit the data towards the user through a channel or a transmission medium. And from that physical layer, the data will be traveled back towards the application layer.
So that's all for today's lecture. If you have any question, you can write it down, and we will discuss that question in class inshallah. Thank you. Allah Hafiz.